Unit 1, Module 1, Lesson 1 reading. Why do some continents have matching shapes? Nearly 100 years ago, a scientist named Alfred Wegener began an investigation. He wanted to know if Earth's continents had always been in the same place, or if they had moved. Wegener proposed that all continents were once part of a supercontinent called Pangaea. Over time, Pangaea broke apart and the continents slowly drifted to their present location. Wegener proposed the hypothesis of the continental drift. The continental drift hypothesis suggested that continents are in constant motion on the surface of Earth. Wegener looked at the coastlines of continents that are now separated by oceans. He saw similarities in the shapes of the continents, including the continental shelves. For an instance, Africa and South America seemed to fit together like pieces of a puzzle. Wegener knew that he needed evidence to support his hypothesis of continental drift. The most obvious evidence was the puzzle-like nature of the continents, but other scientists were very doubtful of his hypothesis. Wegener needed more evidence. How do rocks provide evidence that continents move? Some of the evidence used by Wegener to support his idea of continental drift came from rock formation on the continents in the southern hemisphere. Evidence from rock formations. Many rock formation and mountain ranges on the Australia, South America, Africa, India, and Antarctica all seem to have formed in the same way at the same time. Today, geologists know that there were large-scale volcanic eruptions on the western coast of Africa and on the eastern coast of South Africa hundreds of millions of years ago. Geologists have studied rocks from these eruptions. They determined that the volcanic rocks from both continents were identical in chemistry and age. More evidence came from the rocks that make up two mountain chains in Europe and North America. The Caledonian Mountain Range is in the northern Europe, and the Appalachian Mountains are in the eastern North America. Rocks in these two mountain chains are similar in age and structure. Both are also composed of the same rock types. If you could place North America and Europe next to each other, these mountain chains would meet. They would form one long, continuous mountain belt. Evidence from the glacial features. Another clue used by Wegener to support continental drift came from glaciers. When Wegener pieced Pangaea together, he proposed that South America, Africa, India, and Australia were located closer to the South Pole 290 million years ago. He suggested that a large ice sheet covered much of these continents. When the ice sheet melted as Pangaea spread apart, it left rocks and sediment behind. Wegener studied the similarities of these sediments. Wegener also studied glacial grooves. Glacial grooves are deep scratches in rocks made as ice sheets move across the land. Wegener found glacial grooves on many different continents. By studying these grooves, he was able to determine the direction that the ice sheet moved across the joined continents. Evidence from coal deposits. Coal beds are in Antarctica, a polar climate today. Yet coal formed from fossilized plants that lived long ago in warm, wet climates. This meant that Antarctica must have been warmer and wetter than these plants were alive. Wegener used this evidence to conclude that Antarctica must have been much closer to the equator sometime in the geologic past. How do fossils provide evidence that the continents moved? There are many animals and plants that live only on one continent. For example, lions live in Africa but not in South America. Because oceans separate the continents, animals cannot travel from one continent to another by natural means. However, fossils of similar organisms have been discovered on several continents that are now separated by oceans. Evidence from fossils. Fossils of a plant called glossosaurus have been discovered in rocks from South America, Africa, India, Antarctica, and Australia. Today, these continents are far apart and separated by oceans. The plant seeds, which were large and heavy, could not have traveled across the oceans. The figure below shows how some of the continents were joined as part of Pangaea 250 million years ago. The lighter area on the map shows where glossosaurus fossils have been found. Notice that the plant ones grew in parts of 5 continents: South America, Africa, India, Antarctica, and Australia. Because these plants grew in swampy environments, this region, including Antarctica, were different from how it is today. Most of Antarctica is covered in ice sheets. No swampy environments are found there now. What it was missing. Wegener supported his continental drift hypothesis until his death in 1930. Wegener's ideas were not widely accepted until nearly 40 years ago. Why were scientists skeptical of Wegener's hypothesis? Continental drift is a slow process. Wegener could not measure how fast the continents moved. Wegener also could not explain what forces caused the continents to move. The mantle under the continents and the seafloor were made of solid rock. How could continents push their way through solid rock? Wegener needed more scientific evidence to prove his hypothesis. The evidence for drifting continents was hidden on the seafloor. During Wegener's lifetime, scientists did not have the tools to determine what happened beneath the oceans. Wegener also could not have known what the seafloor looked like. The evidence needed to be proved continental drift was not discovered until long after Wegener's death.